Hi, everyone. Just wanted to take a minute to talk a little bit about classifying polynomials. So by that, really, we're talking about naming them in terms of their terms, number of terms, and their highest degree. All right. So a couple pieces of information on this one. It's really important, number one, to know what a polynomial is. So a polynomial is just any old kind of function, right, where we do not have any um, variables, so x, y, z, whatever, that have exponents with the denominator, right? So you wouldn't want something like with 2/3. So you don't want anything in a radical. Um, and then the individual terms would be the parts in between the adding and subtracting, right? So this would be a term, this would be a term. The degree is the sum of the exponents of all variables in that term, right? So this term has degree 2 because there's only one variable here and it has 2. Remember, if nothing's written, it's 1. So it'd be 3 plus 1, which is 4. So the degree of that would be 4. The degree of the whole polynomial would be the degree of the largest term. All right, so let's go through this. So the given expression it represents a polynomial. And the reason it does is because see how none of these are fractions. Okay, if any of your exponents are fraction, not a polynomial. The polynomial is a blank. So monomial means there's only one term. Binomial, as you would probably have guessed, 2 terms. Trinomial, 3 terms. And then none of the above would essentially just be if there's more than 3 terms. All right, so it is a binomial, right? There's 2 terms, right? Because there's only one thing that's separating them. So 1, 2. And it has a degree of, remember we went through this, 2, 4. You go with the highest degree of 4. Okay, there we have it, right? Because the terms are separated by addition or subtraction. All right, let's do another one. Determine if the expression is or is not a polynomial. If it is a polynomial, state the type and degree of the polynomial. All right, so that would we have a variable, because that's an s, in the denominator. We don't want that, so no, not a polynomial. Okay, you cannot have negative exponents, or because if it's in the denominator, that'd be the same as having a -1 exponent. You can't have negative exponents in a polynomial. All right, as you can see here, not a polynomial. All right, let's do another one. Determine if p to the 4 is a polynomial or not. Well, it is, right? It's just something. It's not a very interesting one, but it is one. The polynomial is it is a monomial. There's only one term, right? There's no addition or subtraction or anything happening in there. Just p to the 4th, and it is degree 4. All right, let's do one more for good measure. Make sure we're on the same page. All right, so determine if the expression is a polynomial or not. If it is, state it is. Okay, so this 6 is on the denominator, but that's fine. Okay, so it would represent, we just can't have a variable down there. So we have 1, 2, 3 terms, so it is a trinomial, and it has a degree of what's the largest. We have 4, 2, 5, so 5. By the way, the terminology to go with 5th degree is quintic. The terminology to go with the 4th degree is quartic. You don't usually use those. Sometimes you just say it's a 5th degree polynomial, 4th degree. Third degree is cubic. Second degree is quadratic. And first degree is linear. Okay. So that is just a few pieces of information on that. Now, there is one other important thing that we need to talk about in terms of polynomials, and it is rewriting it in standard form. So rewriting it in standard form really comes down to making sure you have the degrees in descending order. All right, so you have 4 here, then we need the next largest degree. So the next largest is 3, so that's going to go after the 5x to the 4. Then we have the 4x, which has a larger degree than the constant. This term right here with no variable, that is a constant term. Okay, there's no variable. It essentially has a, an x to the 0th power, right? So that is going to be the smallest. That should always come last. So when we rewrite this, we do 5x shift 6 to the 4th minus x to the 3rd plus 4x plus 1 divided by 6. All right, there you have it, right? See how it's in descending order? Even though there's no squared term here, there's no x squared, it would go in front of the 4x if it existed. Okay. No, you don't have to put the 1. You can put the 1 if you want it. Let's do another one just to make sure we're certain. So we need to put the largest one first. What is my largest one? 2x to the 5th. What is my next largest? I have a 5, which we just covered. I have a 3, 1, 2, 0. So I need the 3 minus x. And you're probably wondering, why am I bothering to go through all this? Well, it's good to have them in the correct order for what we're going to do next with addition and subtraction, because you need to line things up. Okay? Minus 10x squared minus 8x plus 5. So obviously that can be a little tedious when you have large things like this quintic polynomial. So yeah. All right, but anyway, that is how you rewrite them in standard form as well. Let me know if you have any questions, and have a great day.